Hey everybody, it's your local Chem Geek, and today I'll be explaining the topic of energy in chemistry. Now, energy is a very important topic to chemistry because energy makes up almost everything that we know in existence. Energy is difficult to explain, but there is a textbook definition. The textbook definition is the ability to do work. In other cases, it can also be the ability to produce heat. Energy today is classified into two fundamental parts. There's potential energy and kinetic energy. Potential energy is energy that an object obtains due to its position and composition. An example of potential energy would be a car at the top of a ramp. Now, the car at the top of a ramp has potential energy because gravity wants to pull it down the ramp. Kinetic energy, on the other hand, is energy that an object has due to its motion. Kinetic energy depends on an object's mass and velocity. Mass is expressed by lowercase m, and velocity is expressed by lowercase v. The formula for kinetic energy is kinetic energy equals 1/2 times mass of the object times its velocity squared. Moving forward, the two most important laws that you need to know to understand energy and how it works are the first law of thermodynamics and the law of conservation of energy. Now, the first law of thermodynamics explains that energy in the universe is constant. That means that energy cannot be created or destroyed. The law of conservation of energy also follows the first law of thermodynamics and states that energy is not created or destroyed, but instead converted from one type of energy to another. This means that as the car is at the top of the ramp, it has potential energy. As it goes down the ramp, it turns into kinetic, and when it reaches the bottom, it turns into potential once again. The conversion of the energy that this toy car has is quite simple. Once again, it goes from potential to kinetic to potential once again. But there's a third type of energy being expressed as it goes down this very simple example, and that is heat. Now, with this short ramp, you might not be able to tell, but in a realistic standpoint, when the car goes down the ramp, the wheels cause friction as they move against the wood, and that's called friction heating, which produces heat. And that actually converts some of the kinetic energy that's being used to move down the ramp into heat, which is left on the wood and on the tires. On the topic of heat, it's important to know that all objects have thermal energy, some more than others, as long as their thermal reading or temperature is above absolute zero. And absolute zero in Celsius is -273, and in Kelvin it's 0. As we discussed, energy can be found in the position and mass of an object. But not only that, it can be found in the bonds of molecules that make up an object, and that's called chemical energy. Chemical energy is released when an object goes through a chemical reaction. The chemical reaction has two parts. It has a system and its surroundings. A system is a part of a universe that we're focusing on, which has the reactants and the products. And its surrounding is everything else which is affected by the reaction, or the centralized system. When a physical or chemical reaction takes place, it can be classified as endothermic or exothermic. In an endothermic reaction, the system takes in heat from its surroundings, while in an exothermic reaction, the system releases heat into its surroundings. A great example of an endothermic reaction is the physical reaction when an ice cube is in any liquid. Now, normally the liquid is warmer than an ice cube, so the ice cube, being the system, brings in heat from the liquid, and that is considered an endothermic reaction. An exothermic reaction would be water boiling. This is because the water is the system, and heat is being transferred to the air around it, and the air is considered the surroundings. Thanks everyone for watching, and hopefully you learned from this video.